Alright, welcome back, Titans. We're on to episode 4 here. No pump-up music, as it was widely discouraged after the last video. We're on to episode 4, though, the binomial theorem. We're still in section 12.2. If you want to follow along in your book, page 708, our goal here is to use the binomial theorem to expand a binomial that is raised to a power. So let's go ahead and jump right into this here. What if I have the problem expand a plus 3 to the 5th? What does that even mean? Well, we know that something raised to a power means you're going to multiply it by itself that many times. So for example, I've got a plus 3 times a plus 3 times a plus 3 times a plus 3 times a plus 3. Well, we learned a few chapters ago that when you multiply these, you're going to start by foiling. If I foil these first two, I get a squared plus 6a plus 9 by foiling these first two here. Okay. And then I've still got a plus 3 times a plus 3 times a plus 3. Next, I would just FOIL the next one. A squared, that'd be a cubed. A squared times 3 is 3a squared. Then I go 6a times a, 6a squared. Then I go 6a times 3, 18a. 9 times a is 9a. And 9 times 3 is 27a. Or just 27. And I'd still have a plus 3 and a plus 3. And I'd repeat the process 2 more times. And eventually what I would do is I would come up with this really long answer of a to the 5th plus 15 a to the 4th plus 90a cubed plus 270 a squared plus 405a plus 245. And that would be my final expanded answer. So expanded is just written out, no multiplications, no exponents, as far as the whole thing raised to 1, just like that. Well, that could get really, really interesting if you got lots and lots of numbers to do. So what we did instead was we came up with this binomial theorem. And it's the sum, and basically we're just adding terms. You saw in the last term, you're adding terms. Well, the binomial expansion is actually this a plus b to the n. I take that n to the 0, n choose 0, n choose 1, n choose 2, all the way to n choose n. And then I take my first term and I raise it to the exponent, and then I work my way down. You'll notice a to the n minus 1, a to the n minus 2, a to the 0 eventually. The second term I do the opposite. I start with b to the 0, work my way up, b to the first, b squared. And that will actually come out with an answer. So what the heck does that mean? I'll show you here. Well, if I want to expand a plus 3 to the 5th, that means I'm going to have n is 5 now, a is a, and b is 3. So I would plug this out, and I'm going to bring them all up here and just show you step by step. So the first one, my exponent, that'd be my n, so I start at 5, choose 0. Then I go 5, choose 1. 5, choose 2, 5, choose 3, all the way to 5, choose 5. Whatever that exponent is, that's what you start with your combination. Those are your coefficients down here. Then you start with your first term and raise it to that exponent. So I go a to the 5th. And then I start going down one in each term. A to the 4th, a to the 3rd, all the way down to a to the 0. Then you go ahead and go with your second term and start at 0. 3 to the 0, 3 to the 1st, 3 squared, 3 to cubed, all the way up to 3 to the 5th. And then you just go ahead and do those things. So like 5 choose 0 is 1. A to the 5th is just a to the 5th. 3 to the 0 is 1. 5 choose 1 is 5. 3 to the 1st is 3. 5 choose 2 is 10. 3 squared is 9. 5 choose 3 is 10. 3 cubed is 27. 5 choose 4 is 5. 3 to the 4th is 81. 5 choose 5 is 1. A to the 0 is 1. And 3 to the 5th is 243. Then I'll multiply 1 times 1 is 1. 5 times 3 is 15. 10 times 9 is 90. 10 times 27, 270. 5 times 81, 405. 1 times 1 times 1 is, or times 243 is 243. And I get my answer. So instead of multiplying all those out, I was able to actually just use this and come up with that answer using those combinations. If you need to, rewind this, watch it again. We'll go over some more here, but very, very important that you're getting what's going on right now. It's a little difficult, definitely. Looking at another example. Now I've got x plus 2 to the 4th. So 4 would be my n. So I start with 4, choose 0. Then I go 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. First term, start with it raised to the exponent. So x to the 4th, then x cubed, then x squared, then x to the 1st. Second term, start with it raised to the 0. And it's going up, 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th. Multiply those numbers out. Right there, right there, right there. And you can see how it goes. 4 choose 3 is 4, 2 is 8. And we end up with x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. Alright. Getting that exponent, starting at that combination, working your way up. Getting the first term, starting at the exponent, working your way down. Next term, starting at the exponent of 0 and working your way up. That's the key. That's the key, and that never changes. Alright? Moving on here. There is one shortcut. Instead of those 5 choose 5, 5 choose 4, 5 choose 3, 5 choose 2. You can use that, or you can use Pascal's triangle. Pascal's triangle is actually created. You'll notice on the outside there's always ones. So you start with 1, and then you keep ones going on the outside. Well, on the inside, 1 plus 1 is 2. Then you'll notice 1's on the outside, 1 plus 2 is 3. 2 plus 1 is 3. 1's on the outside, and then you just work your way in. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So notice that's where I'm getting these lines. And this actually describes the coefficients in the expansion of the binomial a plus b raised to the n. And if your n is 0, you start up top. If your n is 1, you start with here. These are your coefficients. If it's 2, you start right there. If it's 3 here, 4, and so forth. Okay, these would be your coefficients. Again, what the heck does that mean? Let's look at an example using Pascal's triangle. Up top here, I'm just going to remind myself, okay, n is 0, n is 1, n is 2, n is 3, n is 4, n is 5. Okay, just a reminder. Well, if we look at a plus b squared, n is 2, so I'm going to use these. Notice what my coefficients are. They're 1, 2, and 1. Right there, that tells me what those coefficients are. The rest stays the same. Second term starts at the exponent, or first term starts at the exponent, works its way down. Second term starts at 0, which is just 1, works its way up. Okay? Looking at two other ones here. We have to the third. The third would be this one right here. Coefficients are 1, 3, 3, and 1. Come from right there. We look at to the fourth. We're looking here. Coefficients are 1, 4, 6, 4, and 1. Right there. Alright, so Pascal's triangle, just a little kind of shortcut to help you out there. Well, let's look at one here and do an example. So I've got to the fifth. To the fifth is this line right here. So that tells me what my coefficients are. So I'd just go ahead and write those down first. 1, and I'd have a 5, and I'd have a 10, I'd have a 10, and I'd have a 5, and I'd have a 1. Those are my coefficients. Write those down. Then I move on to the next part, which was same as before. Write this first one raised to the exponent to the fifth. Work my way down. Third, squared, first, 0. Then I go to the second term, and where do I start? Start at 0. So I've got, let's not use that color. I've got negative 3 raised to the 0. Then I go negative 3 raised to the first. Negative 3 squared. Negative 3 cubed. Then I go negative 3 to the fourth and negative 3 to the fifth. Now I do a little math here. Well, this is just Negative 3 to the 0 is just 1, so this is just x to the 5th. This is 5, x to the 4th. 3, negative 3 to the 1st is negative 3. This is 10, x to the 3rd. Negative 3 squared is 9. This is 10, x squared. Negative 3 to the 3rd is negative 27. Plus, I've got, what do I got left here? 5, x. Negative 3 to the 4th is positive 81. Here I've got 1 times negative 3 to the 5th, which is, I believe, 241. 243, sorry. Okay, so I'm just working my way through this. Then I go ahead and finish it out. I've got x to the 5th. 5 times negative 3 is negative 15, x to the 4th. 10 times 9 on the next one is 90, x cubed. 10 times negative 27 is negative 270, x squared. 5 times 81 is 243. And 1 times negative 243 is negative 243. So I just expanded that there by using Pascal's triangle. You can use Pascal's triangle, or you can use the and choose R methods. It's kind of your choice, sir. Again, rewind this, watch it again, try to pick up on the steps that we used right there. If you want, go ahead, use your book, look at some examples in your book, follow along there, do some problems. It's got different steps there as well. This is the end of episode 4. Thanks for watching. Remember, we've got that quiz on Tuesday covering this first section and the second. A little tougher stuff today. Expect to come back on class on Monday and do quite a bit of work. Have an awesome, awesome rest of your day. Go Titans.